Okay, so the key insight that we get from the statistical discrimination model is that when a worker's race or gender or sexual orientation or other such characteristics does provide useful information to the firm about that worker's productivity, because it's a signal of some other characteristic or for whatever other reason, firms will make higher profits when they discriminate on the basis of those characteristics than when they don't. And because of the fact that in a competitive economy, profits are driven towards zero, this should lead us to conclude that if a firm doesn't discriminate when it's profitable to do so, that firm will be driven out of the market. So whereas the taste-based discrimination that we looked at in last lecture is going to be driven out of the market, statistical discrimination is going to be preserved in the market. The next model that we're going to look at, the Cote-Lowry model, takes this logic, but it extends it one step further by asking how being the subject of discrimination, how facing discrimination in the labor market affects the decisions of marginalized workers. In other words, what we're going to do is we're going to think about how firms' discrimination against, for example, black workers is going to affect black workers' willingness to invest in skills that would increase their productivity. And essentially what Cote and Loury find, what Cote and Loury determine in their modeling exercise, is that under certain circumstances, prejudices against a group of workers or a group of people can become self-fulfilling prophecies. In other words, when firms believe that one group of workers is less productive than another, for example, believe that black workers are less productive than white workers, that reduces the incentives for black workers to invest in their own productivity, and as a result, those negative prejudices end up coming true. And the tragedy of this, as we'll discover, is that in this context, even if everyone perfectly understood what was happening, in other words, even if nobody actually believed that black and white workers were different in some sort of intrinsic way, no individual firm or no individual worker would have the power to break out of that negative equilibrium. Okay, so to understand this, let's think through a slight simplification of Cote and Lowry's model. In this model, let's imagine that there's two kinds of jobs. You're either a laborer or you're an engineer. Engineers are different from laborers in two ways. The first is that they're going to have higher levels of productivity than laborers, and they're going to be paid a higher wage than laborers. But the second is, engineers are only going to be productive if they're skilled. That is, people can only produce as engineers if they've invested in costly and difficult skills. Now, from a worker's perspective, a worker will always prefer a job as an engineer than a job as a laborer because of the fact that engineers are paid more money. So a worker who's not qualified to be an engineer will still like to take the job because they would like to get that additional pay. From a firm's perspective, however, it's only going to be worthwhile to hire an engineer if that engineer is skilled. So a firm would like to hire skilled workers, they would like to not hire unskilled workers. However, and this is going to be a crucial piece, firms can't directly assess whether workers are skilled. Instead, the best they can do is administer a qualification test and decide whether they think it's likely enough that a worker is qualified to be worth hiring them on the basis of their scores on that qualification test. Okay, so let's make this a little more concrete. Let's say that firms pay engineers a wage of $100,000 a year. That unqualified engineers, we'll say whether you're qualified or not, S equals 1 if qualified, and S equals 0 if not qualified. If S equals 1, a worker will produce $200,000 worth of stuff if they're an engineer. And if S equals 0, they'll produce 0. So if we think about the firm's decision, right, what the firm wants to do, the firm would like to hire any worker from whom they expect to earn a profit. In other words, from whom the profit they'll earn if the worker is skilled times the probability of the worker being skilled is going to be greater than the loss they're going to incur if the profit is not skilled times the likelihood the worker is not skilled. So we'll think about this by saying that your expected profit is going to be the probability that the worker is skilled times what you earn if the worker is skilled, which is going to be 200,000 minus 100,000, 100,000, plus the probability that the worker isn't skilled times the profit you earn if the worker isn't skilled, which is going to be 0 minus 100,000, right, or negative 100,000. And they'll hire a worker as long as their expected profit is 0, so if it, or greater than or equal to 0, right? So what this is going to mean, 100,000 times the probability that S equals 1, right? Plus probability S equals 0 is 1 minus the probability that S equals 1. I'll say minus that times 100,000 greater than or equal to 0, right? This is going to be 200,000 times the probability that S equals 1 greater than or equal to 100,000. So we will hire as long as the probability that S equals 1 is greater than or equal to 1. Right? So if it's more likely than not that a worker is actually qualified to be an engineer, it'll be in a firm's interest to hire that worker. Now, the way that the firm is going to decide whether a worker is qualified or not is that they're going to administer a test. And if the worker passes the test, then we'll get Z equal to 1. So if they pass the test, Z is going to equal 1. We'll say that the likelihood that you're going to pass the test, if you're actually skilled, is 100%. So the probability that Z equals 1, given that S equals 1, is 100%. But there's also some chance that you'll pass the test by luck, even if you're not qualified. In other words, the probability that Z equals 1, if S equals 0, let's say is 1/3, right? So you're sure to pass if you study, right? You're sure to pass if you actually possess the skills, but you have a 1 in 3 chance of passing anyway, even if you don't possess the skills, right? So from the firm's perspective, the decision the firm is going to make is, are they going to find it worthwhile to hire a worker who they see has a passing test, given that there's some chance that that worker didn't in fact have the skills necessary? And in order to understand this, we need to switch over to thinking about the decision faced by a worker. Okay, so let's start out by thinking that all workers are identical. They all have exactly the same abilities. They all have exactly the same characteristics in every way. And for each worker, the decision that they face is whether to become skilled or not. Let's say that the cost to become skilled is going to equal $20,000. And so the question is it worth it to pay $20,000 to increase your likelihood of being hired as an engineer rather than being hired as a laborer? And let's say we said that the wage of an engineer is $100,000, right? Let's say that the wage of a laborer is going to be $40,000. So to start with, let's imagine that the firms have made a decision that they'll hire anyone who passes the test. They won't hire anyone who doesn't pass the test as an engineer. So hire anyone who passes the test, right? Who has the equal to 1. So what this means is a worker's decision about whether to study for the test or not, right? Whether to become skilled or not, is going to come down to whether their earnings minus their cost of education are greater as an engineer, greater after studying or without studying. So we can say that your earnings, if S equals 1, really your expected earnings are going to be $100,000. Expected earnings, $100,000 because you're sure to be an engineer, minus $20,000 because you had to pay to study, right? So you're going to end up earning $80,000. If you don't study, in other words, if S equals 0, you don't actually acquire skills, your expected earnings are going to be your earnings if you pass the test by luck and become an engineer, times the likelihood of that happening. So 1/3 of the time you'll be an engineer and you'll earn $100,000, right? And 2/3 of the time you're going to not pass the test and you'll have to work as a laborer and earn $40,000. Right? So 1/3 times 100,000 plus 2/3 times 30,000, or 40,000 is be 40,000 plus 20,000 is $60,000. So what we're going to conclude from this is it's going to be in your interests to study in order to ensure that you're going to be hired as an engineer. Right? Your earnings, if you become skilled, are higher than your expected earnings if you don't bother becoming skilled. Okay, so given this, is it going to be in the firm's interest to make this offer, to say that they'll hire as an engineer anyone who passes their test? And to see this, let's think about the likelihood that someone who passed their test is in fact skilled, given the decision rule of workers. So we can say that there's basically two ways that you can become skilled, or that you can pass the test, right? Two ways to pass. For z to equal 1, right? The first way is be skilled. And the second way is be unskilled but lucky. And the likelihood that someone who passed the test is skilled is just going to be the proportion of all people who pass the test who are skilled. Right? So we can say that your probability of being skilled, given that you pass the test, probability that s equals 1 given that z equals 1, is going to be given by the number of people who are actually skilled over the number of qualified people plus the number of unqualified lucky people. Right? And this in turn is going to be the fraction of people who are actually skilled. So the probability of among all workers of being skilled over, right, probability of any worker being skilled plus 1/3 times 1 minus the probability of being skilled. Right? What this is saying is essentially the total pool of people who pass the test are skilled people plus 1/3 of unskilled people. So the likelihood that someone who passed the test is skilled is just the likelihood that someone is skilled over the likelihood that someone is skilled plus the likelihood that someone's unskilled who passed the test. And given the fact that all of our workers are going to choose to be skilled, given that they expect to be hired as an engineer if they pass the test, what we're going to conclude is the probability of being skilled is equal to 1, so this is just going to equal 1. Since that's greater than 1/2, the firm is going to be better off offering people who pass the test a job, given that they expect that people who pass the test are in fact going to be skilled. So far this is all a wonderful, happy story. Right? Essentially what we've said is, it's in the firm's best interests to offer people who pass the test jobs, as long as they think that the people who pass the test are actually skilled, and it's in the workers' interest to actually become skilled if they expect to get a job at the end. Because everything aligns well, right, the Nash equilibrium, the equilibrium where everyone is doing what's in their own self-interest, no one has a reason to deviate, is for all workers to study, all firms to hire workers who study. However, so far we haven't talked at all about discrimination, right? We said this was a model of discrimination, and we've presented a model so far where all workers are the same, and all workers end up getting good jobs and living happily ever after. So now let's think about how this is going to change, how this model is going to adjust, once we add in differences between workers based on race and the presence of racial discrimination. So let's say that we've got two kinds of workers, let's say white workers and black workers, and that there's no actual differences, no intrinsic differences between white workers and black workers. White and black workers both have a cost of $20,000 of becoming skilled. They both have the same productivity if they become skilled and they get hired as engineers. However, let's say that because of past racism or prejudice or for whatever reason, firms start out with a belief that no more than 1/5 of black workers could possibly be skilled. So firms believe that the probability of being skilled, given that you're black, is less than or equal to 1/5. And this is a belief, right, that's not justified by anything. It just comes out of nowhere, right? It comes out of history or upbringing or something like this. So now let's think about, given this belief, whether firms are still going to be willing to hire black workers who pass their test. In other words, whether firms are still going to be willing to hire black workers for whom z equals 1. So what we need to think about here is what firms are going to believe the probability is of being skilled given that z equals 1 and that a worker is black. And this probability, just as before, is going to be given by the ratio of people who are actually skilled and people who pass the test out of luck despite not actually being skilled among black workers, right? So this is going to be probability of being skilled given that you're black over the probability of being skilled given that you're black plus 1/3 times 1 minus the probability of being skilled given that you're black. Right? And what we're going to say is they'll hire black workers if that probability is greater than or equal to 1. Right? So are they going to be willing to hire? Well, we know that they believe that the probability of being skilled given that you're black is 1/5. Right? So they'll hire if 1/5 over 1/5 plus 1/3 times 4/5 is greater than or equal to 1/2. Right? This thing here, let's multiply the top and bottom by 15, is going to be 3 over 3 plus 4, which is equal to 3/7, which is less than or equal to 1/2. Right? So what we're going to conclude is, I'll say is not greater than or equal to 1/2. So what we're going to conclude is, because firms believed that they couldn't see no more than 1/5 of black workers could possibly be skilled enough to be an engineer, when firms see a black worker apply who passed their test, right, who appears to be qualified to be an engineer, they're going to think that the likelihood that that worker passed by chance and isn't actually qualified is too high to risk hiring them. And as a result, this prejudice is going to lead firms to adopt a policy of hiring white workers who pass their test, but not hiring black workers, even if those black workers pass their test. So how does this affect the decision of black workers about whether to become skilled or not? Well, if you're a black worker and you become skilled, your earnings are going to be $40,000, right? The earnings of a laborer minus $20,000 is $20,000, right? If you don't become skilled, you're going to earn $40,000, right? For sure. Essentially, you're not going to be hired as an engineer, whether you become skilled or not. So as a black worker, it's not going to be worth it for you to acquire the skills necessary to become an engineer. And as a result of that, not only are the firms going to be correct in their belief that no more than 1/5 of black workers are skilled, in fact, in equilibrium, no black workers will be skilled. In other words, the presence of this stereotype results in an elimination of the incentive for black workers to become skilled, and that in turn confirms this stereotype. So given all of this, we're going to end up with a stable equilibrium where only white workers are hired as engineers and only white workers become qualified to be engineers. So let's say that we're in this situation and you're able to convince a firm that this is exactly what's happening. In other words, you fully convince an owner of a firm who hires engineers that black and white workers are equally capable of being engineers, and the only reason that black workers are not as likely to acquire skills as white workers is because of the fact that they face discrimination. In that case, could you convince that firm to hire black workers? Sadly, you couldn't. Because if that firm decided to start hiring black workers who would qualify, who'd pass the test, the pool of black workers who would pass the test would be entirely composed of workers who passed by luck. Because of the fact that all the other firms are discriminating against black workers, no black worker would have an incentive to study for the test and become a qualified engineer just on the basis of a single firm deciding that they would start hiring black engineers. So a firm that decided to start hiring black engineers would find that the black engineers weren't qualified and would lose money as a result. And likewise, if you talk to any individual black worker and explain to them that the only reason they couldn't get hired as an engineer is because of this prejudice, you couldn't convince any single black worker to change their behavior either. And so as a result, even if everyone, once we start with this initial unjustified prejudice, it creates a situation where there's no way to teach people out of this negative equilibrium. So how could we get out of this equilibrium? Well, Cote and Lowry argue that we could do this in two ways. The first is with a legal mandate that firms give hire black workers using the same employment standards that they use for white workers. In other words, you say if you're going to hire qualified black, or you're going to hire white workers who pass the test, who have z equals 1, you have to hire black workers who have z equals 1. And if this law was passed, and if it was enforced, it would solve this problem. Because in this case, black workers would then know that they were going to be hired as engineers if they passed the test. That would create an incentive to get skilled. And almost immediately, or within one generation, we would end up with the affirmative action policy not even being necessary anymore, because black workers would be skilled at the same rate as white workers, and firms would no longer have any reason to discriminate against black workers. They say we could also achieve this result. Let's say the government can't tell whether you pass the test or not, so they can't require equal qualification standards for black and white workers. We could also achieve this result by enforcing a quota, that the firm had to hire the same number of black workers as white workers, or had to hire the same fraction of black applicants as white applicants. If the firm had a quota such that they had to hire black workers, they would reasonably start with black workers who passed the test. And so the result would be the same. The result would be that black workers who passed the test would be able to get hired, whereas black workers who didn't pass the test wouldn't. This would create an incentive for black workers to become skilled, and we would break out of this negative equilibrium. Now, the last thing that I want to say on this model is that in this negative equilibrium, where black workers are discriminated against, the result is that everybody suffers. This is not good for anybody in this model. It's not good for black workers because it limits their possibilities, right? It means that black workers who are perfectly capable of becoming engineers would be stuck working as laborers. But it's also not good for the firms, right? The firms could be making more money by hiring qualified black engineers. And so they're also suffering because of this equilibrium where black workers are barred from opportunity. And in fact, there's good evidence to suggest that breaking out of these sorts of discriminatory equilibriums has been an enormous boon for the US economy. So there's a paper called The Allocation of Talent and US Economic Growth by a team of economists, Say, Hurst, Jones, and Klenow, that estimates that 20 to 40% of US economic growth from 1960 to 2010, so kind of the second half of the 20th century and then plus a little bit, can be attributed to the increased integration of women and minorities into high-skilled professions. So they point out that in 1960, only about 6% of doctors and lawyers were women or minorities in the United States, and that by 2010, that had gone up to about 38% of doctors and lawyers. So we'd gone from almost none to about 2 out of 5. And with reasonable assumptions about the distribution of skill in the US economy and the returns to skill to various occupations, they argue that that integration, that increased availability of highly skilled workers in highly skill-intensive occupations has an enormous benefit for everyone. Okay, so this is the Coate and Lowry model. In the next model, we'll be working through similar ideas, but with an even darker twist.